Continuing on with the review, we have now our CS 113 final review, section 4, part 2. Here we have another graph. This time it is an undirected graph with weights. And what we'll be doing here is running Prim's algorithm and showing each step of the algorithm. Again, we start off with the table the same way where we had V and VS. And basically we want to also draw the final tree. So again, we start off at node A. It doesn't say where to start, but we'll assume that we start at node A since that's the lowest value in our table. So we start at the node A. We look at the nodes that are attached to it, 20 and 10. And so we write 10 from A to B and say it goes through A. And for node D, we also write 20 and say that goes from D to A, and that's a 20. So next we go, we pick the shortest length, which is A to B, so B gets moved up from VS to V. And now we look at the links between A and B. So now we have a link of 20 for C, 20, and that goes through B. We have a link of 50 that goes to E, and those are our last two links. So the next link that we would pick is most likely C. We could pick also the link D. However, just due to the fact that C is the first vertex that we come up with, we would probably pick C if we're going from top to bottom. So the next vertex we pick is C. And then we look at all the links in between A and C here. So we have the only additional link that we've gained is this 30 to F. So now 30 is written here for F, and that goes through node C. So after we do that, we look at all the values here, and A, B, and C are all in our V. The next value that we come to and pick is D, because that has the lowest value of 20. So 20 is, so now we take D from VS to V, and we look at the additional links added for that. So adding D into this, we get two additional links, 40 going into E, which is greater than the current value there. So, or no, that's actually less than the current value because the current value is 50. So we would cross off 50 here and write 40, and that would go through D. For node E, and we would write 70 to node G here. Okay, we next pick the smallest value here, which happens to be 30, which is the C to F value. So after D, we pick F. We look at the additional links contributed by node F, which is 30 and 40. So 30, we look here and see that would be going to E, which is less than what we previously had of 40. So we would cross off 40 and write 30 to E, and that was going through F. And we would write 40 going to I from F. We now look at the additional links that we would pick. And the next smallest link is this 30 to E. So we remove E from VS and put that up into V, and we add the additional links if applicable. 40 is already D is already in our V, so we don't need to worry about that link. H isn't in our V set, so we add 50 to our table going through E. For H, and that's the last link that we have to add. We go through our table and find the next smallest value, which happens to be 40 for I. So we use I and move that up to from VS to V, and we look at its additional link, which is 60 in this case, which is 60 to H, which is greater than our current 50. So we don't do anything, and we're done with I. We next find our next smallest value, which happens to be H of 50 here. So H goes from VS to V. There's no additional values here that we need to go because the additional link that H adds is 80, which is greater than what we currently have for G, which is 70. Finally, we go and pick up the next lowest value, which happens to be G and 70, and he goes from VS to V. No additional links are needed here because we're now visited all the nodes. So here's our table of Prim's algorithm, going from all the vertexes, the values, the cost of that vertex, or the value from A, and how we get through that link. So here's our visited order of the nodes that we visited and the order that we visited them in, and then this gives us our table here of the following algorithm. So this is the cheapest network that we could build that would connect all the nodes with each other.